Hi everybody, welcome back to our class. This is Unit 2 in our course of teaching engineering ethics, and you should be watching this if you have completed Unit 1, including having done the exercise and the review materials. So if that's the case, then let's move ahead. For today, our topics are going to be where does engineering ethics belong in the curriculum? This is I think, controversial topic, and of course it depends a lot on the general curriculum that you have at your institution, and many other things. So we'll explore this. There's no fixed or set answer. But there are various options, and we should all consider those options. One option is that there are specific courses which are devoted to ethics. A course in engineering ethics, for example, and maybe it's required of sophomores or something like this. This is one option that I'll explore a little bit. Then another option is putting modules devoted to ethics or engineering ethics within specific courses, targeted courses. And there are various ways to do that. And there are questions that raises, such as what level do we want to do this at? Is it something that should begin during the freshman year? Or do we want to use it as part of the capstone experience? Or both, or that and other things? We'll talk about that. When do we introduce ethics to engineering students? And introducing ethics, as I indicated in Unit 1, is a bit of a funny topic because everybody, of course, or we assume or hope, I guess, at least, that everybody has been introduced to ethics. We're not beginning de novo. They have been thinking about ethics on one level or another ever since they were, thinking about what's right and wrong to do and why they should obey their parents or, many other things like that. So how to introduce it so that it grasps the issues which are very important for engineers to understand is the question. Capstone ethics, in my opinion, and I think it's widely held opinion, and I think it's something that is widely endorsed, for example, by ABET and other professional engineering review organizations. The capstone definitely should have some ethics component, but how is the issue. Then I want to talk a little bit about co-curricular activities and what we might do to teach ethics to engineering students as a co-curricular activity. That may not be the exclusive approach, although in some programs almost everything is done in a way in a kind of co-curricular activity. But again, just like our main question of where does engineering ethics belong in the curriculum, how you integrate it with co-curricular activities is dependent on the structure of your program. But I want to talk a little bit about that and suggest help you be aware of the rich possibilities that are inherent in certain kinds of co-curricular projects. And then finally in this unit we'll talk about the relationship of teaching ethics to problem-based learning. So let's get going. Ethics in the engineering curriculum. Should it be in the engineering program? I think the answer is certainly yes, and we have discussed that in Unit 1 to some extent. But that doesn't answer the who, what, when, where, and why questions, which are very important. Who should be involved? And I want to pose this question of who on the level of student and the level of the teaching faculty. The answer is everyone. It's important that ethics be as much a part of the engineering curriculum as any of the essential skill sets that engineers use. Of course, every engineer has to have computer competency. Every engineer has to be capable of doing math. Every engineer needs to be able to speak clearly and explain things. And ethics is in the same category of all of those other skill sets. It's not something that we can say is optional. It's not something that is specialized. It's not something where only those people who have trained in ethics have anything to say about it. It's got to be something that everybody is involved in. In our first unit, I was making some parallels with medicine and medical ethics. And a parallel may be useful to consider here because in a modern hospital, there are always a group of people who are certified to comment on and advise on crucial situations where there are ethical questions. There are ethical consultants. Every hospital, I think, has people, and the title may be slightly different. And usually the title is given to not only physicians and surgeons, but also to nurses and also to people who are in other aspects of patient service in the hospital. And when a crucial ethical decision needs to be made, for example, to remove an individual from a life support system, this group of ethics consultants are called together and they discuss the situation and ultimately make a recommendation. But the recommendation is made to the attending physician who must ultimately make the decision. And that means that every physician, whether or not they are part of this ethics consultancy group, has to be involved in thinking through the ethical issues. The same thing is true with engineering. We may have people who specialize in ethics and who give advice and who offer workshops and so on and so forth, but it is something for everyone. I can't emphasize more than to say that ethics is really one of the aspects of engineering that's right at its center. It's something that needs to be as much a part of ethics as cost estimation or as project design or as the principles of testing and prototyping and all of this. These are integral to ethics, integral to engineering, and ethics must likewise be integral to engineering. That means that all of our students need to be exposed to it in a formal way and learn about it, but it also means that every faculty member needs to be involved in it as well. So even if your institution follows the model of having specific courses in engineering ethics taught by engineering ethicists, that does not mean that other faculty don't need to think about it. Other faculty need to think about it very much, and ethics should be brought up in every class and in relation to every project that students do. So the answer is everyone, with no exceptions, needs to be actively involved in the teaching and learning and evaluating of ethical concerns within engineering work. Okay, when? Well, I think, you may say, is it something that we should teach, in the sophomore year? They have so much that they're doing in the freshman year that we don't want to overwhelm them. Or maybe it's something that, because of its comprehensiveness and because it, in a sense, presupposes an awareness of other engineering issues, maybe it should be postponed until the senior year. My answer is that it should be taught formally and informally throughout the full engineering program, whether it's a 3-year program or a 4-year program or a 5-year program. Ethics should always be part of the teaching. In order to make that work, obviously, you cannot only have standalone ethics courses. Even if, in other words, you choose as a department or as an institution to have a standalone ethics course, that is insufficient to satisfy the needs that there are for the teaching of ethics within engineering. It really needs to be somehow part of everything. So that may mean that specific courses each year of a student's program have been designated as having a special task for including ethics, but whether or not you do it that way, all courses ought to, in one way or another, address ethics. So how is that to be done? That's a big problem, and it's one of the biggest problems that we're exploring in this course. But part of the answer comes when you consider where should it be done. And my answer is that it should be done in the places where real engineering work is being done. And that means in the laboratory, that means in the studio, that means in the makerspace. That means that when students are sitting down and making things, which is, maybe the primary or most fundamental activity of engineering, ethics is always part of the process. A lot of work in ethics may consist in testing a device to see if it really does operate according to the, let's say, EPA in the United States, Environmental Protection Agency requirements. Will it produce the degree of consistency or purity? Is it too noisy? Does it pollute? Is it safe? All of these questions that have to do with the welfare and well-being of individuals and communities, these are part of ethics. And you figure it out in the context of making things. And it's not simply fulfilling a specification, because certain issues have to be thought through the way ethicists do. We all agree that stepladders should be stable and safe and reliable. But we also all agree that stepladders are, by their very nature, going to put people into a slightly risky situation. And so the individual using a stepladder has to be responsible to be sure that they're using it safely. But how much responsibility can we give to the user? And how much, sort of cautionary structure do we need to build in? These are questions which obviously indicate that you need to think something about what can I expect of my end user. Is this something that will be in the home or only in restricted environments? Is this something that children may have easy access to or be tempted to gain access to? All of these kinds of questions. And so these are practical, hands-on kinds of questions and a dimension of them has to be addressed when doing prototyping or when doing modeling or when testing equipment and so on. So let's start with one option, the specific course in ethics. And the photo here is of a lecture hall, I think at Purdue University, a well-known and excellent, I think, engineering school. And I don't know what course this is, but I'm hoping that it's, if it's an ethics course, not the only course in ethics. Yes, there are advantages to having a specific course in ethics, although having a specific course in ethics does not mean automatically a lecture course in ethics. It does not mean that you're going to stand up and tell somebody about the principles of ethics and say, learn these and come back and give them to me on a test and write a term paper. There's a lot of value in doing it that way. But if you do it that way, you need to do more if you're hoping to produce an engineer with the right kind of depth and ethical consciousness. So some of the advantages of teaching ethics is that you'll develop skilled people who can teach ethics and know how to make it vital and know how to present very effective case studies and know how to assess and evaluate student performance in ethics and all of this. But those advantages, I don't think, need to be indicative of having a standalone ethics course. Because all of those sorts of abilities and skills and knowledge sets can be shared very well with faculty at large. And not every faculty person teaching ethics needs to cover all of ethics, certainly not. What they must do and should do is make sure that the ethical questions and dimensions related to the specific branch and focus in ethics that they're teaching are brought up and are seen to be essential as part of the project work and are introduced and evaluated in ways that make that kind of seriousness very, very clear. So the question of whether or not there should be a specific course in ethics is a function of what your larger curriculum is. And if your larger curriculum has room for it, and you tend to do things by specializing them in the courses, then a specific course in ethics can certainly do a good job. And there are many textbooks these days on engineering ethics. When I began teaching in an engineering school, I had taught for a few years already in a liberal arts environment, but I joined the faculty of an engineering school, and my assignment, the reason I was hired, was to develop a program in engineering ethics. And at the time I was doing this, engineering ethics was not widely taught, and if one were to look for materials about it, they would be very, very hard to find. Nowadays, that's not the case. Nowadays, the abundance of materials on engineering ethics is extraordinary. There's so much stuff, and so much really good stuff, including many, many textbooks. So there's no reason why you cannot have an academically rigorous course in ethics that focuses on engineering ethics and is taught in the kind of environment you see in this picture. But I don't think it's the best way to do it. And if you do it, I think it should be supplemented by the introduction and reflection and sort of incorporation of ethics questions and issues into every other aspect of engineering. And that's very feasible. The teachers of engineering ethics need not be, and probably should not be, professional ethicists. It's not a specialty in that sense. It is something which everybody needs to own and share and be part of. Now, one way, if you don't choose to do it as a standalone course, is to build modules dealing with ethics into your other courses. And there are at least 3 issues that this strategy raises. Again, you can't discuss it or answer it apart from considering the total structure and operating economy of a course. But the issues are which courses, and perhaps some courses are more suitable for including an ethics module than others, simply because perhaps the amount of material that you have to cover. You can't introduce a new module without displacing something else. That raises the second issue, which is the issue of integration. If an ethics module sort of stands out as a separate topic that doesn't connect to the other topics in the courses, then it's not well designed, I don't believe, because ethics ought not to be a topic which is segregated from the others or set alongside of the others. It's a topic in which, when you're talking about whatever, choice of materials, the amount of energy required, whatever the topic has to be, there are ethical dimensions and aspects to that which can be brought in. And so you may want to have a module that explains why it is that ethics is part and parcel of basically everything else that an engineer does. But the goal ought to be sure that ethics is well integrated into the main stream of the course's work. At what stage in the course? Well, I think the answer, generally speaking, is throughout, but if it is throughout, that means you have to introduce it early on, practically right away. So the fact that ethics is an aspect of engineering needs to be acknowledged early on. Now, I don't think you have to acknowledge that you use computers or that mathematics is expected, although you may say at the beginning of a course, we do not require high-level mathematics in this course, or there's no need for it, or something like that. Still in all, a level of mathematics is always there, and a kind of mathematical thinking is always expected. But because ethics is not seen still as truly integral to engineering activity, it is important early on in the course to say, yes, ethics is part of our considerations here, and you are going to, among all of the other levels that you think about, also be thinking about the ethical aspects of this. The scope is got to be natural. Your ethical questions have to relate naturally and obviously to the engineering work that you're doing. If it seems contrived, if it seems added on, if it seems superfluous, if it seems as though you just do the engineering and then sort of apply a patina of ethics afterwards, then you're missing the point. So any ethical consideration has got to have a genuine and real connection to the engineering work that is being done. Safety is an example. The distribution or use of a device is an example. The clarity of limitations that a device has is an example. The impact of the device on the community that will be using it is an example. All of these things are naturally connected to the engineering work and should be formulated in ways that truly show that naturalness and that natural continuity. Now, there will be skepticism about the adding of ethics. Maybe, if we do our job well enough, in a couple of student generations from now, this will no longer be the case. But for now, students need to know why ethics is being included. Most students, at least in my experience, have chosen engineering because they have a kind of clear idea of what engineers do, and they think there are certain concerns that they won't have to deal with. They have a conception of precision and exactitude and purpose that they associate with engineering. And with that mindset, ethics may seem as though it just doesn't fit in. It's not naturally part of engineering. But when you talk about engineering as that kind of practical activity which makes the world in which we all live and the world which is going to endure for future generations, it becomes, I think, clear to most students that engineering is really a discipline about caring for and protecting people. Again, I often draw the analogy with medicine. I don't think people going into the medical profession at any level have the idea that they don't need to think about how medicine impacts the quality of life of individuals and communities. I don't think they need to be told that there are issues which will conflict with individual values or cultural traditions. But in engineering, even though that's absolutely as correct as it is for medicine, it's not something which is intuited by engineering students, at least in my experience. And so it needs to be explained to them. And it needs to be explained in a way that seems, entirely consistent with engineering work. You have to be very careful about how you talk about things. If you say, well, now we're expected to add engineering, or rather add ethics into engineering, you've lost the game. You really need to believe it in order to do it. And I think that if you think truly about what engineering is about and what it does for the world, every kind of engineering, I think you will have no trouble understanding this. But students need to be assured that it is as central and important as it really is. They're going to have their own expectations or presuppositions and biases that go along, not only about what engineering is and whether or not a concern with ethics is proper for an engineer, but also certain ethical points of view which are deeply their own. Because, as we were saying in the last unit, ethics comes from the whole way in which we as humans think about what's good and right and proper and what human dignity is and what responsibility is and what justice is. And so your students have, whether or not they are prepared to articulate it in precise terms, but they all have beliefs that govern how they look at the world on those topics. Which means to say that you have to not only acknowledge that, but respect it and allow those views and those values to become part of an implicit conversation throughout the course and throughout the 4 years of teaching engineering, so that they're completely comfortable that their professional lives as engineers are an honest and genuine expression of their ideals and expectations for themselves as decent human beings. Now I say, finally, that you can lead a horse to water, but, and what I mean is, you can't just say you must learn ethics, because if you do that, a few students will say, well, gee, you know, that's interesting, and I've already thought about that, but most students are not going to recognize it as a topic that they want to get involved in, not at the beginning. And so you need to be a little bit seductive about it, or coercive. These are not the right words. Each of them has implications that I don't mean. But you need to make the thinking about ethics in the context of engineering just completely natural, and so they just will do it in the same way that they're going to recognize that coding for computer science is important, or measuring dimensions, or doing proper schematics and diagrams, or preparing the inputs for 3D printing. All of these things, of course, they know this is part of doing the job correctly, and the goal that you have is to make sure that they know that ethics is just like that. Now, ethics definitely needs to be part of the capstone course. The capstone course, the senior design project. There we have the opportunity for the student to design something, to work on a project the way they would work in industry, to have all of the considerations that they would in industry, or as they would in their own startup, or as entrepreneurs, or as project managers, or people working in NGOs, whatever kind of project they have, where they're designing something and prototyping it and bringing it to fruition, so that it can be seen as having solved a problem, and representing good design, and having been tested properly, and have a sense for how it is going to be distributed or used in the real world. All of these real world concerns need to think about the social responsibility which engineering always has. You're introducing something into the world, you're changing the world. You need to recognize that if it's going to last and be of value and be something which is truly beneficial, doesn't just, solve a trivial sort of problem, but something that's truly beneficial, it has got to be done with attention to and awareness of the social impact, the human impact, the question of, is this a good thing? Is this making the world a better place? Is this just? Is this hurting people? And so on. This is what we want our graduates to know. Many people have said that, sort of engineering is a kind of universal language, or design is kind of a universal language. If I'm building a bridge in Minnesota, or I'm building a bridge in Bangladesh, I'm going to build a bridge that has the same kind of structural integrity. It's not going to fall down. It's going to last. It's going to be reliable. Well, our graduates are entering out into the world. Engineering graduates are rarely not involved in some kind of international work. Even if they never leave their hometown, they're part of a chain of production and distribution and design which is global. They're very often in communication with colleagues and partners around the world, even if they don't travel there. Many times their products or the result of their design will be put to use or distributed elsewhere. And so it means that one needs to think globally about what is good and what is beneficial. The capstone course creates an ideal opportunity for students to recognize the nature of engineering as a truly worldwide global enterprise for humans under many situations. We can give lots of examples, and all of you can give many, many examples about this. But the problem is that you need to be open in your design, in your product development, in your problem solving, to how the work that you're doing is going to be received or understood in situations quite different than your own. And so I think that, you know, the engineering capstone, since it's the main thing before we send our students off as graduates into the world, is a place where it's imperative that these questions be straightforwardly acknowledged and students required to think about them and cite how they're going to respect the expectations in various settings. Okay, now we've been talking about courses, and I want to think about the teaching of ethics in co-curricular activities as well, as a part of an internship, as a part of service learning, as a part of what a student might do as a service project that takes him or her beyond his or her engineering work specifically. Maybe a student project or student activity where students from business and students from arts and sciences and students from nursing and students from social work and, you know, all of the different possibilities across the university come together and work. It's also the case that co-curricular activities present good opportunities for students to gain experience with industry. And some industries have been quite emphatic about trying to make social responsibility a part of what they do. And one such company is Siemens. And I thought that I would let us look at a short presentation about a project undertaken annually by Siemens involving their employees to express a kind of social responsibility. So pay attention to this, and then I'll have a couple of things to say about it.
Every year, Siemens Controlling and Finance Audit takes on a corporate social responsibility project. This year, the village of Ban Apa in northern Thailand was selected. With a group of 14 volunteers from 9 different nationalities, we traveled to the village with the intention of building 2 public washrooms and water tanks. Arriving on site, we realized that the village has an even more serious problem: lack of fresh water. Therefore, the villagers asked us to build a 1.6 kilometer water line from a dam in the hills to the village and 2 water tanks to hold the water. Besides using the water for their everyday use, the villagers required to develop their homestay business, which has become a sustainable source of income for the villagers. During the 2 weeks of the project, we worked and lived in the village, sharing the everyday lives of the villagers.
We are here in Ban Apa village. 200 people living here. In dry seasons, we have no enough water. That's why we have the project to bringing water from the mountains to the village.
I'm excited. We woke up around 4 a.m. to roosters. Now we're up about a mile away in the woods from camp, and we're getting ready to start building a dam. Pretty excited. I think it'll definitely be possible, but it might be a lot of hard work.
Today's day 1 of building. We're all excited about this. Guys are already cutting down some trees down there where we will build our dam. Yeah, we're collecting some rocks. You can see we're in the middle of the forest.
The dam is where the water line starts. It blocks the river and causes the water level to rise to ensure a consistent flow of water to the village. While working hard on the project, it was important for us to also take time and play with the kids. After all the fun, it was time to get back to work.
It's good to be the CFA. Much easier than this.
In the beginning of week 2, the pipes were delivered. To construct the foundation for the tanks, we made concrete by mixing cement, sand, rocks and water.
See the water coming out at the end into the tanks, and all the villagers looking very happy because they have water. It's been a really fantastic experience. So hats off to the whole CFA team and also to Mad Venture, our partners in this. I think a really fantastic and worthwhile project. And I'm just amazed at the amount of blood, sweat and tears that has gone into this project from everyone. So well done.
This is the last day that we spent in Ban Apa village. We've had 2 weeks of a very intense project, building a water line and 2 water tanks. Very happy to have the village developed, and we are now saying goodbye.
CSR was one of my best working experiences.
I'm proud of what we achieved as a team out there.
It felt good to make a difference.
One of the best experiences in my life.
This project reminded me very much of a project annual student project done in my university where engineering students would, as a group, really from all levels, all 4 years, along with several faculty members and actually usually their spouses and maybe others in the department. And they traveled to a rural village, in their case it happened to be in Sri Lanka, and worked on a project which they did in coordination not only with the village but also with Habitat for Humanity. And they spent close to 2 weeks, same scale as the Siemens project. They're working in a village and doing all things. And the impact that it had on the students was extraordinary. They began to realize that the skills that they had, they could apply in quite ordinary tasks, pouring concrete or building, framing a house and so on, that they worked closely with the villagers side by side. They also socialized with them and played with them, as you saw here. And in a sense, it allowed them to become able to see themselves as not only engineers, but as engineer citizens or citizens of the world, and in a way also people who had a vision of what the good life was and how to help that for the future and for the present. In a way, the three hats that our friend here has, engineer and citizen and philosopher, this is kind of the outcome that this sort of project can produce. Sometimes they're expensive, but very often there's financial support, especially if you partner with industry, you can do it. But of course, there's no need to travel to the other side of the world to do it. You can find projects of this sort in the very community where your institution is without any trouble. If you look around, you will. It doesn't need to be 2 weeks. It could be one afternoon a week during the regular school semester. There are many ways of doing it and organizing it, but it by its very nature is integrative. It draws together the kind of concerns of what is good and just and proper and compassionate and beneficial with issues of straightforward civic responsibility and issues of engineering skill. So think about the possibility of distributing the courses or the instruction in engineering ethics between formal coursework and co-curricular work. And within the formal coursework, think very much about how to distribute it among the entire program. Now, I want to say that ethics is most effectively taught to engineers within the problem-based learning process. In this way, it doesn't seem to be contrived or artificial. The process, as indicated in this very, I'm sure familiar to most of you, circle of problem-based learning process. The identification of the problem, kind of brainstorming, thinking, what are the possible solutions, the application of knowledge, the learning what needs to be done, developing of skills, and then the prescribing of courses of action and carrying it out. This, at every stage of the way, is the way ethical reasoning goes as well. This is how you do ethics. And so long as in problem-based learning, if you acknowledge that the problem is in its fullness going to include ethical dimensions, then the problem-based learning process is I think, the most effective and best way to teach ethics to engineers. I mentioned here the concept, the CDIO concept. CDIO is a very interesting way to put together an engineering curriculum. It was developed by some faculty at several universities, including MIT. And it says that the engineering process, the engineering process ought to be used in the designing of engineering curriculum. But I like to think about this CDIO as one of the best ways to understand what the engineering process it is. CDIO stands for conceive, design, implement, and operate. Each level is what engineers do. And it's the same sort of progression as you see in the problem-based learning circle. So when one looks at engineering in terms of problem-based learning and in terms of CDIO, then it's very natural and very compelling to include the human, the cultural, the social, the economic, the political, and ultimately, therefore, all of them together, the ethical aspects of engineering projects, and to instill them in students. Okay, so for our exercise, I'd like you to think about co-curricular projects as a good way to approach the teaching of ethics. Maybe not the entire way, but a way that really will, I think, have an extraordinary impact on the quality of learning for your students and how it will help with the, having graduates that you're really proud of who do important things in the world. Again, with these exercises, I hope that you can do them collectively in a group. If you're not able to do it with a group in the course, at least get together with a few people and brainstorm. Just open-ended way. What kinds of co-curricular projects can you imagine that would be feasible in your institution to set up? Some factors you need to think about in planning this have to be realistic about the maturity and independence of your students. Some students, quite frankly, you don't want to put in certain situations, at least not with a lot of supervision and guidance. Other students that you may have could very well take on all sorts of sensitive, even activities and projects, delicate issues of various sorts. So take that into consideration. Sort of prosaically, when is the best time to do this? Should it be a summer vacation kind of project? Is it something that you can do during the regular year? Many institutions have service learning programs built in, or co-op learning programs built in, or internships during the semester as an option. Think about what is available structurally in your institution and where would it be most effective in terms of servicing the most number of students to have a project like this. Think about whether you want to partner with industry or with local government or with an NGO. We want students to realize that engineering ethics is about how engineers work in the world and in the communities where they live, and this may mean working together with industry. It may mean working together with some other local institution, a hospital, for example, a school. It may mean working with a community-based organization or an international organization like Habitat for Humanity, and so on. Think about what would work best for your school. There's not one right way to do this. There are many excellent ways to do this, but you have to make sure that you have the right fit between what you can do at your school, at your university, what your students are capable of doing, and what you have the financial and other resources available to support, and so on. And will it be done in conjunction with a specific course, or perhaps will be one way to earn academic credit, might be a required experience, might be optional. Think about those things so you're planning a curriculum, and share your results on the forum. You might, work out your results as though it were a report of a faculty committee to the department, or to the dean, or something like that. Put it into a real-world context. I think you'll find it helps you think very creatively about how ethics can become a vital and important part of the engineering curriculum. Then to review, I'd like you to look at your own department's program or your own institution's program and list down the courses that you think would be appropriate to include an explicit ethics component. Then I would like you to imagine or design, at least in a preliminary way, an ethics module for one course that you regularly teach. And put both of these things up onto the forum as well. We'd like to have as much interactivity among all of you as possible. You all have a lot of experience and come from diverse backgrounds and so on, so that your ideas are not all going to be the same, and so sharing this way is really important. And then finally, we have a little quiz this week as well, so take a look at that, and when you have it done, submit it to me, and as I said last time, we'll comment on it and send it back to you with the comments. Okay, that's the end of Unit 2. Hope that you enjoy this project approach, and that the exercise will be expansive, as I hope it will be for all of you. Okay, see you next time.